Hi guys, welcome to B Bytes lecture 8 data science course, right? So till now we have discussed about what is statistics, what are the types of data, right? What is IQR, what are outliers, right? So today we will be going deep into the IQR part, right? So till now we discussed that IQR is basically the difference between the 75th and the 25th percentile, right? So here Q3 is the 75th percentile and Q1 is the 25th percentile. And if we if you just talk about the data, what is data? Data is nothing but raw facts and figures, right? It is unorganized, unprocessed information. Information is the processed data, right? When something has a meaning, that is known as information, right? So that is also very important. Now come to the outlier part, right? We discussed about that the upper range, the formula when we calculate the upper range outlier, that is Q3 plus 1.5 into IQR, right? IQR, right? And when you just calculate the lower range, that is Q1 minus 1.5 into IQR. So I just asked a question in the last lecture that what is this 1.5? We just named it a specific multiplier, right? I told that 1.5 is nothing but a specific multiplier that we use to just increase or decrease the range in the outlier, right? If the range of the outlier is upper range, so that we will just add 1.5 into IQR into the 75th percentile, that is the Q3. But if the other range is lower, means it is less than the upper range, it is less than the normal range, you can say. There is a firstly normal range, then is the upper range, and then is the lower range. But when the range is less than the normal range, that is the lower range. So when we calculate the lower range, that is there we just subtract 1.5 into IQR from the 25th percentile, right? So but why we are just taking 1.5 here, right? We can take 1, we can take 2, we can take 2.5 even also, but why 1.5, right? So the question comes here, why 1.5? It can be 2, 2.5 also, but 1.5, I would like to say, that is the commonly used specifier, right? You will see that in mostly numericals also we will not use 2 or 2.5, right? We will be using 1.5 as the specific multiplier, right? And you just remember that we just subtract in the formula of Q1, right? And we just add in the formula of Q3. That is the most important thing. Q3 is the upper range and Q1 is the lower range. So it is all about the data sensitivity, right? How sensitive is your data, means what is the pattern of the range in your data, right? That is basically this data sensitivity, right? Is the data going on the upper range only or on the lower range only, right? Is the data increasing from the normal to the upper range, right? If it increases from the normal, then it will the upper range only, then we will just use this formula, Q3 plus 1.5 into IQR. But if the data is steadily decreasing, it is going towards the lower range, so then we will use Q1 minus 1.5 into IQR, right? We will soon be practicing the numericals on it, right? Now come to the another part, right? The denotation for the specific multiplier. So it is basically denoted by K, right? It is basically denoted by K. It is not any standard term, but it may refer to a specific value to determine the formula used to calculate the lower and upper bounds for the outlier. So basically I told that the outlier is of two types, that is the lower bound and the upper bound. You can say the lower range and upper range also. Basically it is lower bound and upper bound. So it is there are the formulas where we use this specific multiplier K. K is having 1.5 value here, right? So now come to the IQR. IQR is another useful measure that we use in dispersion or spread, right? You just simply know that dispersion means spreading out of the values, right? How the values are spread out in the data set, right? It is used when the median is used as the measure of central tendency. This is very important, right? We don't just use the median, right? We just use the we just don't use the mean, we just do not use the mean and the mode. The measure of central tendency that is used here in calculating the IQR, in calculating the dispersion or spread, that is the median, right? Median is one of the most important central tendency in the form of IQR, where we are using this center point is known as median. Median is the centermost value, right? And then you know that this particular graph is very important. It is divided into 50 percentile and 50th percentile, right? The total is 100, and that 50 is further divided into 25 and 25, right? So it is further divided into 25 and 25. So now come to another important part. The next part is about the presentation of data. So now from here, the you can say the topic, the concept of series is starting, right? What is a series? What is a series, right? So basically, series is nothing but the presentation of data. How your data is presented. It is the data is individual data, is the data discrete, or is the data continuous, right? When we will be practicing the numericals now, there we will just I will just show you a data set, and from that data set we will just find out that the data set is individual, discrete, or continuous, right? So basically the series, the presentation of data, is basically of three types, that is individual, discrete, and continuous. So discrete, what is you can say, so individual. First, we start with individual. Individual is what? Here we have only one individual value, right? From the name you can just say that individual means where we have a single value, you can say a single values graph is made in the individual data, right? Where we do not just comparison between the two variables, but there is only a single variable is there in the individual data, in the individual series, right? But when we talk about discrete, here we have a range of data, right? When I will provide you a range of data, so you can simply say that the data is discrete data, where we have the lower and the upper, you can say the minimum and the maximum value, right? So that is basically the discrete data. But when we come to the continuous, so here we have frequency, which shows the repetition of the observation, right? Here we have the frequency. Frequency means how many times your data, your observation is repeated, right? So where the frequency word will come, na? So where you will just see that 2, suppose the number 2 is repeating 5 times in the data, right? So there you can say that the data is continuous data that keeps on going. Discrete means the finite, right? So now come to the most important thing, that is moment, right? What is moment? So basically moment, firstly you know the denotation of moment, that is mu, right? Mu. So here we have individual values, right? It is used with reference to frequency distribution. Here also we have individual values in mu. In when we calculate the moment, it is used with reference to the frequency distribution. It describes two very important characteristics, right? So when we just do the frequency distribution, how the data is distributed according to the frequency, do you know how many times the observations keep on repeating, that the data is spread out by the help of frequency distribution, right? So there we use the moment. Moment means how the frequency is distributed in the form of data, right? So basically the degree of symmetry, the moment is related to the degree of symmetry, means moment is very important, that it will describe the further two terms such as you can say the skewness and the kurtosis, right? So moment is basically related to two most important terms, that is skewness and kurtosis. So firstly we will discuss about skewness. What is skewness? Skewness just gives you the degree of symmetry, how much symmetrical your data is, right? How much symmetrical your data is. So basically it gives the degree of symmetry. So next term is kurtosis, right? It gives the degree of peakness, how your graph's peak is made. Is it the normal peak, right? Is it the higher peak or the lower peak, right? We will discuss it further also. Basically the definition of skewness and kurtosis, that these two are related to which term? That is the moment, right? These are related to the term moment. So skewness and kurtosis are the most important terms, where skewness gives the degree of symmetry, right? How symmetrical your graph is. When the graph is fully symmetric, you can say that the mean, the x bar can be equal to median, right? It is equal to median, and it is equal to mode. Mode means how repeating your data is, means how the times of occurrence of a value, right? So when I say that the data is symmetric, that means your median is equal to mean is equal to mode. But that also has a problem. means not every time these all three terms are equal. Sometimes the median is the highest value and the mode is the lowest value, right? Sometimes the mode is the highest and the median is lowest. So that comes into the part of skewness. When I say skewness na, means there is asymmetrical graph, antisymmetric, right? You can say antisymmetric or asymmetric, right? When I say symmetric graph, so there is no skewness, means there is no degree of symmetry, right? Yeah, when I say na the symmetry has a degree, that means skewness is there, right? When I say skewness, means that is anti-symmetric, your graph is not symmetric at all, means the distribution of data can be cannot be 50 or 50, cannot be equal every time, cannot be equal. It can be 75, it can be 20, it can be 25, right? It can be 80 and 20, that all, but it is not equal, right? But when I say symmetric, that is means no skewness, means your data is divided into 50 and 50, means this data, right? This is not there is no skewness here, means this graph is symmetric, right? So that is all about the degree of symmetry, right? So come to the type of moment, right? Means moment R, where the moment of maximum 4 types, right? R is basically the type where when we use the 1, so R will be equal to 1, right? When we calculate moment 2, right? So R will be equal to 2, and similarly mu4 and mu3 will be calculated, right? So basically the moment is all about the 4 types of data, right? You can say 4 types of values, right? So that is from 1 to 4. The range of R is always equal to 1 to 4, right? It cannot be equal to 0, it cannot be equal to 5, right? It is always from 1 to 4, means 1 2 3 4. It can have only 4 values, right? It can have only 4 values, that is 1 2 3 4, right? So further on in the next lecture we will be discussing the formula for calculating the mu, and we will go further deep into the skewness and kurtosis, right? How the data is, you can say, symmetric and non-symmetric, how to find the data, how to find the graph is symmetric or non-symmetric, right? So thank you, have a nice day, meet you in the next lecture, right?